So thank you, Mathworks community, to give me such an opportunity to participate with my project Vehicle Detecting Model with Matlab by MD Salehin Islam. And about myself, I am not an extraordinary guy. I'm an ordinary undergrad student in civil engineering department, and it's my uh, introduction, or is my okay. Next project idea. So one day my senior gave me a task for their transportation research purpose that did count the vehicle and detect the vehicle but with category. For example, is it bus, it is truck, and how many are moved in that point or in that junction. But why? Because when we construct a road or when we construct a bridge, we need to count it for the width or for the budget or for that anything else. So it is very necessary and it is very crucial for transportation engineering. But I think that if I count it in a junction or in a road, how many times can I count vehicle or detect vehicle focusly? This is very important because when you do a road or when you make a bridge, it is very much important that how many peoples are benefited from that. So I think that when a human do the work, it is a very boring task, right? And you can find it when you do it. So it is very boring. So when a human do it, there are multiple errors. Seriously, believe me. So to reduce, what can we do? We can do a CC camera or anything that can record a video. Then it process in a machine through Matlab or Python or anything, and then count the vehicle. Okay, there are multiple models, and seriously, they are many very popular. But I the main reason or main problem is that they are not the perspective of Bangladesh. Okay, so I am from Bangladesh, and Bangladesh, India, Pakistan, Afghanistan, or Myanmar, etc., are the same quality of vehicle, uh, or you can say that yeah, same quality of vehicles are moving on road. For example, bus, truck, rickshaw, CNG, tempo, etc. and etc. But you maybe find in USA, you can't find in USA rickshaw, right? So ultimately, the established model or established uh, things are not appropriate in our region. So I think that why I don't make one. So from that courage, I want to make a model. Okay. Next, methodology. How I make the model. First, I collect image, then prepare dataset, then resize the model with IM resize, conversion of image from RGB to grayscale, then extract the gradients from image with Hawk features. Next, storing the gradients in Matlab, train Matlab with dataset, take an image as input, resize the image, conversion from RGB to grayscale, extract gradients, and compare with the dataset, produce an output. That's simple as that. Okay. Next, the some notable function that I use in the in my model. So first of all, image data store. It is used to include the subfolders which I want that our model will took as a category and collect the image from each category. For example, creates an object to manage and read a collection of image files. Here you see that include subfolder true. That means it will include all the subfolders. Next, level source. It is the folder names and file extension is .png file. Okay. Next is split each label. Okay. So here are two. Here the total image data stored will be divided into two categories. Number one, train image. Number two, test image. So first of all, 90% image of the sample of which I give the model to train it is 90%. If you give me a 10 image of bus, 9 images will be trained our model and one image will be test so that it can uh, it can test that is it correctly say the correctly say the category, and this is okay, and if the total process is organized or total process is done randomly. Next, numeral. It counts the number of elements in an array or cell array. The next is IM resize. I use it to resize the image in specified dimension. Here our target size is 128 pixel by 128 pixel. And then RGB to gray. I use this command so that every image will be converted into gray. But why? The reason behind is if I uh, create a model that will detect a vehicle with the color, it will definitely do error. And to prevent it, I make all the image in gray. Okay. Next, exact hop features. It convert it is RGB image to the histogram of oriented gradients because Matlab can detect an image on gradients very easily. Next, vehicleClassifier. So after training our classifier or after training our model, 10% image will be tested against a trained image model. So first of all, when we run our model, it provides a confusion matrix that tell me how many predicted class will be true class. Okay, this is mainly used for it. And vehicleClassifier, statistical toolbox of Matlab. Okay, next, load. So it is used to load our vehicleClassifier.mat file, which is created from the our data store. Okay, predict is used for predicting the level from the classifier. Okay, so let's go to the code base to check our code how perform. Okay. you have already noticed our model, how it works, and how we can detect a vehicle from image. And we are from at the beginning now, and then after all, when we work furthermore about the model, we can detect the vehicle and count them from an image or video, both. So first of all, what is the problem is now? The problem is, as it is a SVM model, that means support vehicle machine. So there are it already it works about quality, or that means when we put a quality sample, it will work really good. But when we put a large volume of sample but that are not qualityful, it will be very erroneous. And so we need to manually collect a quality of image. Okay, so that's the main problem. And the next problem is there are some error too. Yes, you see some of our test or some of our predicted vehicles are truly predicted by our model. But the problem is when we test 17 sample, it perform out of 17, 12 are correct result, and it gives 5 incorrect result, and the accuracy is 71, which is good but not very good or excellent. Okay, we are not satisfied with the accuracy. We are working to improve its accuracy. So first of all, our challenge is when we improve our accuracy, it will be sharply detect the vehicle, and it can perform the box shape create, or it can be handle a vehicle very correctly, and then we can work the video processing. Okay, and now we can process the video. We can I can give you a sample. For example, if I go to the our model and load a video, you can see it. Okay, so first of all, okay, go to our code and then go to our test video. So when we open and run, here you see the vehicleClassifier.mat, which is our model. So then run it. You can see a errorless result, multiple error. So it is because it can't detect the sharp edge of the vehicle. Okay, and so there are very error. So you can see it. So we are developing it to improve. So but it is very hopeful that we are now process a video with our own model, and seriously I'm very glad to see, showing it. Okay, so now comes to the slide. Okay, stop it. Okay, okay, stop it. Next, our limitation. Okay, so first of all, our main limitation is limited dataset. As I discussed previously, that SVM is totally performed with the quality because it is not like CNN or ANN model. So CNN or ANN model have the intelligence to detect the quality. So when you put large amount of sample, then as CNN or ANN will perform it's better. But why? Because it has the inbuilt intelligence to detect the quality. But when you work with the SVM model, it's absolutely can't detect the quality of the sample. So when you input large amount or large volume of sample, it can't detect about the quality. So it is very erroneous. But when you put large amount of quality sample, then it will perform the best. And here is the problem. You should be manually detect the quality picture or quality sample to detect the vector. Okay. So first of all, limited dataset and quality dataset or sample noise. Okay. So then false positive. For example, in the picture we see a CNG, but it predict bus. Okay. So first of all, to be honest, I need to say you that we prepare our model in the perspective of Bangladesh because when uh, in popular model, for example, YOLO or anything that are not fit for Bangladesh. Okay, so Bangladesh or South Asia or India or Pakistan, that's not fit. So in Bangladesh or South Asian region, we call it CNG, but our model predicted bus. Okay, and YOLO predicted stack. So there is some error. That's not our discussion, but the problem is we need to develop our model so that it should be predict CNG. Okay, so this is false positive. Different angles of image. So first of all, when we load our model, we don't prerequisite you that the image should be vertical or image should be horizontal or image should be front view, side view, back view, anything. We just ask you for image. So our model have very much responsibility so that as we give you a freedom that you can give me an image of in many aspect, so we need to perform different angles of image and the error is so much different image dimension. Okay, you I don't request you to image of 120 and 120 pixel, or I don't request you to collect pixel or give me image of uh, any specific dimension. So your dimension would be very randomly. So this is will be a limitation. Sample of with noise, it is discussed the previously. Unable to detect multiple vehicles. So it is because as you see the when I load a video, there are much error. When it see cars, it predict bus, and it can't predict the sharp edge of the vehicle. So it can't detect a multiple vehicles. Still now, when we develop our model furthermore and furthermore, it will do it. Okay, applications. So before saying our applications, so first of all, I need to say something about it. First of all, it's our model is our in a primary stage. Okay, so we should not expect more anything from our model. But the most important thing or the most uh, important thing is that anyone can develop our model, and it is so easy. It's so easy for their respective country, for their respective uh, 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 for respective country or anything. And because for example here you can see that there are some folder bus, truck, CNG, and motorbike, rickshaw, truck, etc. and etc. So if it performs on US, it can anyone can uh, create a subfolder like any category of vehicle. So it is quietly customizable. So it is very important. So when anyone download our module and want to develop it, so he or she should create a subfolder in the main folder, then collect image of respective category, then run our dataset, then it will be run easily, so much easily. So this is the main feature of our model. Next, well, let us discuss about some applications: vehicle identification in law enforcement, automated toll booth system, vehicle cataloging for parking system, single vehicle focus in AI model training, and traffic survey or planning. Okay, conclusion. So first of all, it is successfully implemented a system for vehicle detection from images using HORG, that means histogram of oriented gradients. Features and SVM support vector machine classifications, and we successfully tested 17 images with 71% of accuracy. Error can be minimized by integrating with deep learning model. For example, YOLO is working on ANN or CNN model. I don't remember it, but something like that. So if we integrate the AI or machine learning model, it will be perform more, and the volume of data set will be it will be used to reduce the model's accuracy, model's errors. So ultimately it is very much important, and then can be developed further to have better accuracy and extended applications. So there are more customizable feature in our model. So this is the main feature. Okay, so future scopes so can be used to develop a system for detecting multiple vehicles from an image, can be implemented in video-based vehicle detection system, can be developed to detect vehicles of a definite brand, can be further developed for real-time vehicle detection. So this is very necessary for transportation engineer. As I'm a student of civil engineer, so there are multiple category of civil engineering, and one of them is transportation engineer. So ultimately, we should or we need to develop it. We need to uh, use it for our research purpose. And then that's all for today. Thank you.